Alright, we're going to talk about the domain and range of tangent and cotangent. I graphed them before and I talked about vertical asymptotes, but I didn't really explain or list what their domain and range is. So to start with, we have y is equal to the tangent of x. And I think it's nice to look at the picture of it, and it kind of helps you to figure out what the domain and range is. So you put 4 tick marks. We'll call the last one 2 pi. 4 tick marks going left, negative 2 pi. And we'll go 1 and negative 1. There are vertical asymptotes. Tangent goes through the origin, then it has a vertical asymptote, goes through pi, then it has a vertical asymptote at 3 pi over 2, and it goes through at 0 at 2 pi. So notice it always goes 0, asymptote, 0, asymptote, 0. So what do we have next here? Negative pi over 2, an asymptote, then at 0. Then we have a vertical asymptote, and then at 0. The picture of tangent, the actual graph, goes up on the right, down on the left. So it looks rather like this. We would say that it has a fundamental period of pi. Tangent and cotangent are the only kind of weirdos, and they do not have a fundamental period of 2 pi, but a fundamental period of pi. Why is that? Because if you consider this is negative pi over 2, and this is positive pi over 2, which is like half a pi this way, half a pi this way, you get one complete cycle. That's what it looks like, and then if you picked it up, it just repeats itself here, repeats itself over here also. So there's their tangent function. It's going to have a domain that I think they're going to describe as x such that x does not equal odd multiples of pi over 2. Odd multiples of pi over 2. It's going to have a range that is from negative infinity to infinity, because it goes from top to bottom, negative infinity to infinity. Alright. And if they ask you, of course, where the vertical asymptotes are, they are at odd multiples of pi over 2. They say, where is tangent undefined? At odd multiples of pi over 2. Now let's real quickly, y is equal to cotangent of x. We'll do that graph also. So just like we did before, we put 4 tick marks, 2 pi. We put 4 tick marks to the left, and we have negative 2 pi. Highest it goes is 1, lowest it goes is negative 1. It's actually going to have vertical asymptotes at every multiple of pi. So notice that's not the same. It does not have the same asymptotes as tangent. It goes, and then it will be 0 at all these locations. And it goes up on the left, down on the right. Up on the left, down on the right, up on the left, down on the right, up on the left, down the right. We also say that cotangent has a fundamental period, of pi. We could say that it has a domain of x such that x does not equal integer multiples of pi. Integer multiples of pi. X does not equal integer multiples of pi. Its range is going to be from negative infinity to infinity, or you could say its range is all real numbers. If they were to ask you, where do the vertical asymptotes occur? Well, they occur at integer multiples of pi, because you have negative 2 pi, negative pi, 0 pi, 1 pi, 2 pi. And that is tangent and cotangent.